I will demonstrate a concept called data object ID and also look at the DDL time for objects. When you create an object in an Oracle database, whether it's 8i, 9i, 10g, 11g or 12c, the behavior is the same. Every object gets an object ID. Object ID is unique across the whole database. So if you have multiple schemas, they do not duplicate object IDs. If you have multiple objects in a schema, they do not duplicate object IDs. But whenever you create an object that has data, like a table or an index, it also has a data object ID. So I will demonstrate that to you now. I've created a table called my transactions and a corresponding index. Now I've populated the table with 100 rows. So the table has data, the index has entries. So I query the DBA objects view for these two objects. In my schema I only have two objects, so I only list two rows in this query. My transactions is a table. The creation was at 1952 and the DDL was 1952 when the index was added. You can see that here 1952 is the index time, and the data object ID and the object ID are the same for the table, for the index. Okay, so here this is a normal situation. You have created a table newly, you have populated it, the data object ID and the object ID are the same. The physical location of the first extent where the header is for the table or the index is from DBA segments, header file and header block. I did not name a table space when I created the two, so they went to my default table space, and that default table space consists of only one file, file number 12. So both went to the same file, but they went to obviously two different physical locations. So the transactions table starts at 10882, the index starts at 10890. Now what happens when I rebuild the index? I am not deleting any rows from the index, I am not adding any new rows to the table, so there is no change in the table or in index size, but I am just rebuilding that index as it is. When I rebuild the index, you will see that the object ID of the index has changed from 79745 to 79746. The table's data object ID has not changed. It remains at 79744. Because I did not drop and create, the object ID remains the same. It's only the data object ID that changes. And the DDL time for the table changes because I rebuild an index. So whenever you rebuild an index, add or drop constraints for a table, the DDL time of the table will also change. But the object IDs remain the same. The data object IDs can change when there is a rebuild. The table remains in the same location 10882, but the index has moved from 10890 to 10898. So the rebuilding of the index has moved the initial location of the index and changed the data object ID and changed the DDL time of the table. So three things happen when you rebuild an index. DDL time of the table changes, data object ID of the index changes, header block and locations of subsequent extents of the index change. So what happens if I relocate the table and rebuild the index? Whenever you move a table, all indexes on the table become unusable. So to make them usable, you have to rebuild them. So that is what I'm going to do, because I move the table without adding rows, without deleting rows, as is of the same size. I just relocate the table with the move command, and I rebuild the index because the index becomes unusable. So I move the table, rebuild the index. Because I moved the table, the data object ID has changed from 79744 as it was earlier to 79747. Because I rebuild the index, the data object ID of the index has changed from 79746 to 79748. The object IDs remain the same. If I were to drop and create, the object IDs would change. But if I do a move and rebuild, object ID is not changed, data object ID is changed. Because I did a move and a rebuild, the DDL time of the table in the index changed. The rebuild time of the index becomes the DDL time of the table, because the index rebuild is after the table move. If I had 4 or 5 index rebuilds, the last index rebuilds time would become the DDL time of the table. Have the locations of the table and index changed? The table was at 10882, it has moved to 10890, and the index has moved from 10898 to 10882. 10882 was the initial location of the table. When I moved the table, that location was free, so when I rebuild the index went into that free location. In this case, it's just a coincidence. It could have moved to any other location, but Oracle preferred to find and reuse an extent that has been freed recently. In fact, you will also notice that the index moved from 10890 to 10898 and the table moved to 10890. So when I relocate an index with a rebuild, or when I relocate a table with a move, the free extent can be reused by any other object that relocates. In this case, in this table space, there are only 2 objects, so they are reusing each other's location. But if I had 100 objects, then there is no guarantee that my transactions table would use the old location of my transaction index. No, my transaction index would use the old location of my transactions table. Any other table or index would have reused that location. But the important point to note is, move of a table changes the data object ID. Rebuild of an index changes the data object ID, also changes the DDL time of the table, and both move and rebuild change the header file and header block. This table space has only one file, so the header file remains unchanged. But if I had multiple data files, they could have moved to a different data file as well. What happens if I truncate the table? Truncating a table does not make an index unusable, so I do not need to rebuild an index. It just truncates the table and the index. So when I truncate the table, the location has not changed. So the initial location of the table and the index is not changed. The initial extent remains the same. That's the default behavior of a truncate table command. Unless you use a keep storage clause or a reuse storage clause and your extent sizes were different. But here in this case, the initial location does not change, but the data object IDs have changed. The table from 79747 becomes 79750. The index from 79748 becomes 79749. So the takeaways are, the first time you create an object, the data object ID and the object ID remain the same. Data object ID applies if the object is a data object like a table or an index or any other object which creates segments. Whenever you rebuild an index, the DDL time of the table changes, the data object ID of the index changes, and the location of the index changes. Whenever you move and rebuild a table with one or more indexes, the table's data object ID also change, the index's data object IDs change, the table's last DDL time is the rebuild time of the last index, and both their locations also change. Whenever you truncate, the locations may or may not change. In this case, the location does not change, but the data object IDs do change, and the truncate obviously causes the DDL time to change. So the key takeaways here are, if you see a data object ID is not the same as an object ID, that means a move, rebuild or truncate has happened at least once. If the data object ID and the object ID are the same, the table or index has never been moved, relocated or truncated. Whenever you rebuild an index, the last DDL time of the table changes. Whenever you move or rebuild a table or an index, the location of the initial extent will change. Whenever you truncate a table and an index, the DDL time changes, the data object ID changes, but the location may not change. So whenever you're looking at database objects like tables and indexes, materialized views which create tables themselves, look at data object ID and know how to interpret it in relation to the object ID. Data object ID being different from object ID, that means at least one move, rebuild or truncate has happened against that table or index. The gap between the data object ID and the object ID does not indicate how many moves or truncates have happened. If I rebuild 100 objects, the gap might have changed. The gap for a table or index might become 100, but for each table index, the rebuild may be only one occurrence, but the gap may be 100. So the gap does not indicate how many rebuilds, moves or truncates have happened, but the gap between data object ID and object ID indicate move, rebuild or truncate has happened. Last DDL time of a table changing indicates that constraint or index has been enabled, disabled, rebuilt, added, dropped, whatever. Changing of the header block of a table or index means a move or a rebuild has happened.